Good morning, everybody. How are we this morning? Good. So, for today's class, I thought we might continue on with our ant-based example. Of a somewhat larger program running in JavaScript. If we recall, we kind of got to the point where we get this little ant falling through the screen. Now, good morning. Now, coming back to this and looking at it with fresh eyes, there are a couple of different things we could do here in order to simulate the collision of the ant with the background, right? The first thing that we could do is we could use a matrix-based approach, but that would sort of severely constrain the ant so that the ant is kind of moving along whole pixel boundaries, right? We're not really talking about acceleration anymore. We're kind of just talking about moving a dot around a maze, essentially, right? So that's one way we could do it. We're not too heavily deep into a physics simulation, so I don't mind tearing up what we already have and going that alternate route. The other thing is we could keep going on with what we currently have, which is a more, acceleration goes towards the center of the Earth. The ant would have like a jump arc, these types of things. One is, so if you want to do the sort of matrix approach, that decomposes into code a little easier, but it's more work to pull off. Whereas the physics-based approach less code overall, but the code will be more complex and involve more formulas. So what do you want of these two approaches? I will leave it to you. How many people would like to do a physics simulation-based approach? How many people would rather do a matrix transformation approach? All right, well, it seems that the physics has won the day. Of course.
What about if we can colors?
Sorry, say again?
Colors.
Colors?
Yes. Is that an idea? Collision detection?
Well, so first, the color doesn't really matter. Think about our model view distinction, right? This is our view. What we really are concerned about is interaction with the model. So let's take a look at the code and remind ourselves what the model was for this program that we were writing last time. So if you recall, we initialize a level array. It's a two-dimensional array. If a cell in that array has a 1, it is ground. If it has a 0, it is not. It is sky. We could modify the engine to paint sky as blue or whatever you like, but that's kind of another step to make it pretty. We don't want it pretty. We just want it to work. So, so basically, the question is, this is kind of the fundamental question now. We have an object which has a position and an acceleration, how do we calculate within a field of ones and zeros how do we calculate when this thing is about to impact something? And how do we stop it before it falls through something? Right? So, if we take a look at the code for update player, this is the code which performs our physics simulation. Essentially, our player has, in this case we're only doing the y component, but you know, we can flesh that out with an x component later. Our y component has a position, a velocity, and acceleration. Every physics simulation step, we add our acceleration to our velocity and our velocity to our position. Right? So, we need to detect when we hit something. Right? Well, there are actually two ways of thinking about it. Either we detect when we are now inside of a block and we pop ourselves up to the surface that we were on, right? Or we start off in blank space, detect when we are about to update our position and put ourselves inside of a block, and we prevent ourselves from doing so. This is the better option, right? Got it? So, in order to accomplish this, we need a function translating coordinates inside of the SVG onto our level matrix. Make sense? Because if we don't have that, we don't know where this thing is with respect to the grid, right? We don't know where it's going with respect to the grid. So, let's write that function. So, the way that we've set things up here I'm going to do a small SVG, but you know, ours is I think 50 by 50. But you know, or it's like our SVG is 500 pixels across with 50 blocks up and down, right? So I'll do a small version with like 4. So if we have you know, this is 0.00, this is 10, 20, 30, 40, 0, 1, 2, 3 indexes, right? 10, 20, 30, 0, 1, 2, 3. So essentially, if we have a dot right here, right? Let's say we have a dot located at 2515, right? We know that 2515 should get us to 1. What mathematical transformation can we perform in order to do that? you can break it up into two operations.
Divide and minus. You can divide and then subtract
Divide by what?
by the number of cells.
Well, not by the number of cells. The number of cells would in this case be 4.
Or divide
Right.
by the width of the cell.
There we go. We divide by the width of the cell, which is in this case 10. So 225 divided by 10 is equal to 2.5. Now, it doesn't matter if this thing is 29 or if it's 21 or even if it's 20. We want it to map to this. So anything within the range 2.0 to 2.9, we want to come out as integer 2. Is anybody aware of a mathematical function that will do that for us?
Floor?
Floor is correct. Very good. Math.floor. So, if we take our x-coordinate, divide it by the size of the grid, the size of the grid cells, and then apply math.floor, this is the formula that will transform a position in the SVG to a position in the grid. Now, it's, yes?
Sorry about that.
Yeah, no trouble.
I didn't get like why we do the grid. Like I didn't get why we like.
Oh, why do we have a grid in the first place?
Yeah.
So the idea behind this game is that our ant character will be able to pick pieces of dirt off of level, carry them to a different part of the level, and then put them down again. So we're kind of doing a little bit of a Minecraft-like simulation.
Oh.
So in order to do that, we need a model where we have our blocks represented in a way that we can modify them, and that makes the level different. Does that make sense?
Like if we work just with the 25 and 15, it doesn't work. Like just working with the point, like compare the
I understand what you're trying to say. Why can't we work with the squares directly? Right?
Yeah.
Why can't we work with the square objects instead? Why do we have this secondary layer in the background? And the answer is because, believe it or not, this makes things simpler to work with, right? So in Java, we've talked about the model view distinction, right? Perhaps they've not done a good enough job, we have not done a good enough job as an institution of like telling you why model view distinction. It's because the model is much easier to work with without any of the view details, right? If we were to work with squares, right, it becomes a lot more difficult for us to work with and a lot more processing for the computer to work with. So like, what are you going to do when you need to know all of your squares? Are you going to like use, document.query selector all square, right? First of all, you might be getting stuff that you don't intend to. And second of all, like you're going to perform that search operation every single time you need that data, right? It's inefficient. Whereas, if we have a matrix of ones and zeros that we maintain in the back end, we always know where it is, it's always correctly formatted, and it's very easy to work with. In the case of this function that we're working on, here, let me code it up and I'll show you how simple it is. So, function, let's call this world space to block. World X, world Y. let level x equal math dot floor, not flu, floor, world x divided by 5. Let level y be the same. Wait, did I say 5? I meant 10.
Yeah.
Yeah, pardon me. My brain's still warming up. Return level at Lx, Ly, assuming it's not reversed. Now, we can devise a fairly simple test for this to make sure that it works. Document, well, canvas.add event listener click function. So mouse, what is it again? It's the event, yeah, or just e dot mouse position. I forget how it. Let me just look it up. JavaScript quick event mouse position. Yes, client X, client Y, that's it. So if we simply console log world space to block of client dot event dot client X comma event dot client Y, right? This now is an event listener that should tell us if we have clicked on a block or not, right? But with reference to our grid. And this is, like we could attach an event listener to every single block in the entire game, but this is somewhat inefficient, right? We've got 50 by 50 blocks. How many blocks is that in total at maximum? Yeah. And that you would have that number of click events listening in the background, right? Inefficient. Here we have 1. So let's load her up and see if this works. Inspect. Console. That Zoom, you can even see the blocks. Click, 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 click. Interesting. So we've got a problem. All right. Time to debug. Yes.
I found, I don't know if you're gonna say something. When you're zoomed out, it clicks up on the errors. When you zoom in, it works.
I was gonna say your LX and LY should flip. So I think all your white space is on the left side.
See, I was wondering about that. LY and LX. Also, so whenever something doesn't work, the first thing you should say is, well, what are my variables doing? So let's console.log event dot client X and client Y. I have a feeling I know what's going on. So if I click over here, I'm getting zeros. But if I click over here, oh, there's an undefined over there. Now here's a question. About here should be close to 0, 0, right? In the top left corner. When I click, I'm getting not 0, 0. 12 seems about right. 141, not so much. These coordinates are not relative to the SVG. They're relative to the window itself, right? So that's also throwing us off. We need to sort of recenter them, subtract the position of the SVG itself within the document, right? So let's do that. Nothing's ever simple, right? We will, so this isn't a waste of time, this testing either, because this is like, I may not have told you this, but this is like what I intend the control scheme to look like. So basically, the idea I had for like how you actually pick a block up is like you have kind of an invisible radius around your player character where a click event on a block will pick one up or put one down. So, good morning. So this is still useful work we're doing, even though we're also making things so that we can test them. So, we just need to know how to get the absolute, or get the relative position. And that's what Google is for. Yes, click event get relative position. Yeah. jQuery, blah! Okay, so you've got page X, current target, offset left. This dot offset left, this dot offset top. Okay. So let's try minus e dot current target dot offset left. Well, perhaps it's useful to see what that is on its own as well. Oh, wait, it's not called event E, it's called event. There we go. That's not going to do us what we want it to. There we go. So let's see here. Undefined, eh? I've been lied to.
I have a question.
Yes?
Can we add like from the first function, like word space to block, can we add like LX and LY to the SVG, like somehow?
Well, that's another approach that we could take. JS get position of element. Get bounding client rectangle. Okay. So, let's see about that. Canvas dot get bounding client. It seems autocomplete knows what I'm talking about, which always is that always helps. See what that says, sir or ma'am. Okay, so that seems to be correct because when I open it up, it's much larger. So, all right, that seems to work. Let x equal this thing minus that thing. Y is the same. There we go. Now, we should have 0, 1s, uncaught. Come on. All right.
I think for why you change client X to client Y, even with client Y.
Oh, yeah, so I did. Whack, whack. There we go. Very good, thank you. It's always nice to have a class that's on top of things. There you go. Clicking zeros up here, even right to the edge. Clicking ones down here. Ooh, that was an undefined. Hopefully we don't get those too often. There we go. So far so good. We can actually, at this point, we could even flesh out the pick up a block, put down a block mechanic. We can then filter that mechanic for the position around the ant. That seems to be where I'm going with this. So why don't we pursue that path for the time being, since we got this working. So we want to, if we want to do things in the typical Minecraft style, it's the, what is it, left click, main click? Yes, main click is your destroy a block, and then right click is your put one back again. So, we could use another function, two more functions. Pick block up, put block down. I think it's a little easier if we use this. Well, we're kind of like, I'd like it to I'd like one that gives me back the coordinates, you know? So, let's say function world space to coordinate. Wx, wy. Well, I think we can actually, now I'm thinking about it. Let's make an object. So let result equal empty object. Result dot block value will be equal to this thing we were returning before. Result dot x will be equal to level x. Result dot y will be equal to level y. Objects are a fun little trick you can use to return multiple values from a function. So now, down here, we would be taking our world space to block, let block equal world space to block. If we console log block dot, what was it? Block val, or I could just say result dot val. That's easier. Block dot value. That should do the same thing. Cannot read properties on defined reading val. All right. Well, I'd have to return the thing, wouldn't I? Whack whack. There we go. 0, 0, 0, 1, 1, 1, 1, 1. Everything still works the way it was. But now, if I log the block that's returned instead of just the value, you can see that I get not only the value of the block, but I also get the coordinates of it, which will be useful when we want to modify the level. So, going back to our event listener, this is becoming user block interaction. When we, so the next thing we have to determine, did we right click on the block or did we left click on the block? Right? Fortunately, this information is stored. Actually I should test to see if right click even works. It's got like, we have to, the right click menu is messing us up. So, let's see. HTML SVG disable right click menu. That'll do. So how about Canvas, instead of doing document.addEventListener, let's attach the event listener to the canvas. Context menu is an event. If we prevent the default, then when we get a right click, we should, it should just not happen. We get one over here, but yeah, there you go. Context menu as an event no longer triggers the right click, or right click now doesn't trigger context menu. Strike that, reverse it, thank you. So, this may even, let's flesh this out into a function. This might function as our right click. We could just turn this into a right click. What it does when you right click right here. There you go. We'll still want all of that. There we go. So right click, we get this stuff. Right click and left click, we get blocks reported. So far, so good. So basically, the difference here, this guy removes a block from the level. This guy places a block in the level. In terms of modifying the model, and this is where using the model becomes very, we start to see the advantage of doing it this way. all we need to do is say, in this case, level at yx is equal to 1. We set it equal to the thing, and then we want to redraw, we want to draw the level again. Now, this is a little tricky because we're not clearing the level before we redraw it, so we'll have to add a routine to clear the existing blocks before we put the new ones in. That's okay. Let's just, this will work to a to a certain level. After both these, we'll want to draw the level. There we go. If I were concerned heavily about modularity, I would notice that the content of these two functions is almost identical, and then I would externalize that. I would say something like function block interaction type, and then I would take all of this, put her in there, type, replace one with type, and then here, block interaction 1, right? The only thing is, I think I might have to pass like the event down as well, so let's just, that's possible, but let's just not do that. This is fine for now. So now, if I click, 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 cannot set property of undefined. Are you even still working? Come on, you. Stop. Did I crash it? Alright. Oh, I know what's happening. Every time I click, I'm adding all kinds of new rectangles, right? If I do that enough, I just have too many rectangles and it crashes the system, right? Like, take a look at the contents of my canvas, right? Like, just watch the scroll bar. Okay. Yeah. Or maybe you're just giving me a console error. Line 88, you say. Level is undefined. Level
So
should be
I
undefined.
think you need to change X and Y to the result. Use the block
Oh!
X dot Y.
That's true. Block.x, block.y. Thank you very much, sir. Yes, except I should do that in my actual source code, shouldn't I? Block.x, y, block.x, there we go. True. You can see, like, it's beginning to chug a bit now. Ah! One appeared. But you can see, like, we got an awful lot of these things now. So, when does it start to begin to chug? At around 50,000 objects. Which is pretty good, actually. But I think maybe we should put that bit in where we clear out the old ones before we put the new ones in. What do you guys think? Yeah? Yeah, okay, let's do it. So, the point of today is like, you guys get to watch me try to code something I've never coded before, and watch me like try to solve things. And also, you know, this is like a try to hone your bug fixing skills kind of lesson. In addition to like seeing some like possibly more advanced techniques than we usually have time to cover. So, yeah, 50,000 nodes, that's a lot of nodes. So, let's see here. In our draw level, we need to first remove all of the squares. So, we want to remove all of the squares, but we don't want to remove the the ant. So one way we could do this, document.query selector all rect. There you go. This might be a little too permissive. This might grab things you don't intend to do. But well, you know what's even easier than that though. This is kind of a kludgy way to do it. Like, well, okay, I'll do it the proper way. Let old squares equal that, or int, so let I equal, or k even, equal 0, k is less than old squares dot length, k plus plus, old squares at k dot remove. Now let's see if we get that same problem. Well, that's interesting. Are those? Oh, I bet that was just aliasing. Yeah, okay. It's very deceptive. You would think that these grid lines would be like whole blocks, but just because of, like, if we zoom in a bit more, I don't think they are actually. Yeah, like it's, yeah, I guess you'll just have to trust me. I mean, if you count along the top, right, it's like 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50. So each one of these is actually 2, even though it looks, like from the, this is an effect called aliasing. It looks like those are like the blocks, but they're actually not. Yes?
I had the same problem, but he actually told me I managed to fix it by setting the stroke of the rectangles too. And it fills in the gaps even when you're doing stuff.
Yes. Or if you want to see the grid lines, you could also set the stroke of the rectangle to something other than the background color as well, which, you know, for this type of thing, sure, why not? It's a pretty good idea, actually. Let's do it. Dot set attribute stroke black. And there, like, it's never gonna come out exactly pretty, you know, but now we can at least see them, right? So there we go. We can remove blocks. Can we add them? As a matter of fact, we can. All it would take to turn this into a rudimentary paint program is to do this on mouse down and mouse, like on mouse down events rather than on click events, so that you can sort of paint with it. Make sense? So the thing though is, with Minecraft, there is a constraint placed on this. You are only permitted, at least when you're not in creative mode, you're only permitted to put down the number of blocks you pull up. Right? So that's fairly simple to implement. We can create a new variable. Let held blocks equal 0. When we pull, we should, it's now useful, like commenting this would be very useful. Pick up a block. Put down a block. When we pick a block up, well, like, if block.val is equal to 1, then we do the thing, right? Held blocks plus plus. If block.val equals 0 and block.val is, or not block.val, held blocks is greater than 0, do the thing. Held blocks minus minus. Fairly simple addition to our logic. We should only be able to pick one up if one exists. If we didn't have this if statement, clicking on thin air would add to our block inventory. We should only be able to put one down where one does not exist, and if we have more than 0 blocks held. Fairly rudimentary. Sound good? Look good? Yes, yes, yes. Very good. So now, if we try to put stuff without picking it up, we can't. If we go there. There you go. It's beginning to look like a thing already. So, now, there are additional constraints that you could put on this. Basically, this is the kind of game, this is the kind of program where you write your initial system, and it's like very, very permissive, so it's not like a huge amount of fun to play because it's just a paint program, right? What makes it fun is adding constraints to the paint program. It's like Minecraft is a little bit like MS Paint, except you have to fight zombies for your pixels, right? It makes it a little bit more dramatic. So another constraint that you could put on, which you could test fairly easily, you're only allowed to pick a block up if it has like an exposed block around it. Right? So you can't just click down here, right? You have to actually work your way down there if you want to get those guys, right? That makes it a bit more like how Minecraft works, but for our purposes right now, we'll call this good enough, and we can move to getting the ant to work. Make sense? So far, so good? Good. So, let's think about the ant now. So, our ant essentially needs to know if he's going to enter a block on his next, on his projected next position. So this is where we calculate his physics update. This is where we actually update his position. So the code that we need to put in needs to go between line 19 and 20. Maybe we'll just add a couple of comments in here as well. Update physics. Update position. Calculate collision. So, our player object has X position and Y position. The X position and Y position, we can use our world space to block function to determine that condition. Am I about to be inside of a block? Right? So, we can say, does player have a, did we just, I think we're going to need a X position on the player object at the minimum. Where are we here? Yeah. So let's just say player dot X position is equal to 30 as well. Cx is player X position. There we go. Ta-da! We now have X position, even though we, we don't have velocity or anything like that working. I know this has been a lot of X position, but no, X position. When somebody's talking too much during a movie, right? So. Let next block equal world space to block player dot X position player dot Y position. The other nice effect of world space to block is, if you'll notice, I performed a little bit of a switch-o, change-o. We put things in x, y, because x, y is how we're used to dealing with things. And the effect of this is to hide the fact that the level is actually yx. We don't have to think about that nearly so much if we're using this function, which is useful. So, world space to block, next block. If next block dot val is equal to 1. You could actually just say next block dot val, but that's okay. Freeze! Else update position. So at the moment, we're going to put something in there, right? But for the moment, let's just make sure that this works this far. Book. Oh. Now, it is not that we you know, like right now, the ant is trapped, right? We want physics to still happen. So what we don't want is we don't want the ant's position to change relative to its last position, right? And we're only kind of getting away with this because the physics, like, the ant's not moving too far each step. So, like, essentially, the amount that he digs into the ground is going to be random and based on how fast he was flying, right? But we can say perhaps player dot y velocity is equal to 0. Player dot no, we want to keep acceleration in place. Acceleration should always be in place because basically the moment you hit something, it would turn gravity off, and then, you know, if you like walked sideways off of a platform, you'd just walk into thin air, right? Kind of like the Roadrunner cartoon. No. So let's undo what we did here. Y position minus equals player dot y velocity. Y velocity is equal to 0. But we can still update our positions. Oh, you see we sank in a little bit there. So this is what's happening. This is actually kind of interesting. Perhaps none of this class is interesting, but it's interesting to me. So this is what's happening. We have the ant whose next projected position is here, right? If this is calculated, we've turned the velocity into 0, right? But what happens? In the next frame, it starts growing again, right? Right? Until it eventually comes to rest very close to the center of the circle. Now, we could fix that with calculus, but I think maybe we best just move on. You should always be aware when good enough is good enough, right? But that's why it does this sort of tunneling towards the ground effect. Yes?
Would it be possible to offset by the radius of the circle? Because that's known in the SVG.
That's true. That's an easy thing to do. Offset by radius of circle. So well,
Every direction would be complicated, I would think.
yeah, it's like you'd have to do this in the direction of travel, you know, because like at the moment we don't know if we are like colliding with a thing above us or a thing below us, right? The same code will work in both cases. So if it's okay, I think we'll just move along. So now that we have collision in the vertical direction, we can do jumping, which is fun. Shall we do some jumping? Okay. So, what do you want for your jump button? Spacebar? Yeah, spacebar seems, that's pretty usual for a jump button, yeah. Let's see. No, I don't have it memorized. What are you talking about? That should work actually. So, I think we can do a little better than that, W3 schools. Come on. It's like keyboard events occur when a user presses a key. A user presses a key. A user presses. Oh, that one says releases. Okay. So that's fine. Okay, so up is release. These two are press. Okay. So, jump! Canvas.add elect listener. On key. Press. Function event. The event should store what key was pressed. Console.log event.key. Let's see what that does. Reload. Open up the console. Canvas is not defined. That's true. That is a true thing. Canvas. There we go. Get out of here, Firefox. Nobody likes you. Oh, does anybody like Firefox? Any Firefox users in there? Yeah? You like it? Okay. I'm sorry I slacked off. There we go. Not activating. All right. Maybe it's got to be a document. Okay. All right. Fine. Awful. Document and key down. Yeah. Key down, you say. Let's try it. I'll try anything once. Ah! I would say, okay, so key is actually like the space character. That's interesting. All right. So, if event.key is equal to space, the final frontier. There we go. We want to do something to the player. So what does jumping do? What does it modify about your physics?
Direction.
Well, yes, direction.
Which is the
X and Y direction.
Um,
Like if we want,
Not, so how, okay, we don't want to modify the position directly.
Through
With
the
velocity.
acceleration and velocity.
Velocity, that's the one. Yes, but acceleration we want to keep constant.
Okay.
So basically, like, your like jump arc should look something like that, right? Which means constant downward acceleration. Acceleration is still gravitational acceleration, still constant. But we just instantaneously go from having zero velocity to having, you know, quite a bit of non-zero velocity. This is a value that we're going to have to tweak quite significantly, so we should actually make it a parameter at the top. Let jump power equal 50? We'll see if 50 works. It might be hilarious results. That is likely to be hilarious results. You never know until you try it. So, player dot y velocity is equal to, let's see here, is acceleration negative here, or is it positive? I guess if I'm jumping towards zero, then I want negative velocity, right? So let's just make the jump power. We want player dot y velocity plus equals jump power. Let's see if it works. So I hope you can see that, like, as we're going through this, although we've kind of, this looks intimidating because we've kind of built it up from, you know, a lot of individual operations. Each of the individual operations is not that large, right? If you break this down in terms of the individual operations, they themselves are hopefully somewhat digestible. This should look fairly digestible, right? So, reload, and whoa. All right. I may have an error when I attempt to jump off of the screen.
You might have a couple.
Yeah. So let's, but we didn't go in the right direction. Let's try knocking that down a little bit. Oh. There we go. So we are getting that error, but we are getting that error when the ball goes off the grid, right? But it's just like last time. It was, the jump was so powerful, we just shot off into space. You know, a more reasonable jump score. Let's try. What do you guys think? 3, 5?
I think that's
Let's try 3, see how we do.
It's very low. I think 5 or maybe 7.
But, here's another thing. We currently have infinite double jumps.
Oh, very nice.
3 seems a bit weedy to me. I think we might turn it up a little bit. Yeah.
7? Or
See, one of the things is, like, because we're working with, like, second order, we're working with a second order function, like, the effective velocity is nonlinear, right? So, it's a little tricky to, like, you know, just find the good value, but that's pretty good. That looks like a good jump to me. So,
change its velocity to.
yeah, we'll do the x velocity once we get left-right motion. But, like, we're pretty close here, actually. We're pretty close to having this thing working, and maybe we can make it a little pretty. So, this guy, you want to sort out the infinite double jumps, or do you care? Yeah, sort it out? Okay, so basically you want a Boolean telling you if you're suspended or not, and if you are suspended in air, you shouldn't be able to jump. Or if you want to put a double jump in, it's like, you know, you have a variable counting the number of jumps you get while you're suspended, and when you're out, you're out. But let's just disable mid-air jumping, right? First we need to tell when we're in mid-air, right? It's very you can do it fairly simply. Let suspended equal false. Let's make it true to begin with, because our guy starts in the air and then he falls, right? For the code to jump, suspended equals true. And in player update, when we hit something, we reset that. Suspended equals true, or false. False. So now, still works. Right, let me see here. Suspended is true. Suspended is false. Oh yes. Well, I'm updating suspended correctly, but I'm not actually using it.
Comparing it.
I need the if statement still. So
Here.
right there. Yep. And not suspended. There you go. And you can see, we no longer have the ability to double jump. Now, this is going to make certain things interesting. We're not at the moment distinguishing between like ground collision versus wall collision versus ceiling collision. So under this, you get your able to jump back. For basically, we've got infinite wall jumps and also infinite ceiling jumps. But this is maybe not like the worst thing in the world, considering our player is an ant. Ants typically can, climb walls with relative ease, given their, anatomical features. I just want to do this though for you. Like he fully interacts with the level too, right? So, okie dokie, making progress. Shall we do left-right motion now? Okay. So, so to do left-right motion properly, we need, well, let me take a look. Maybe we should, that might be a good stopping point. Maybe we should have the break, and then in the next segment of class, we'll do left-right motion. Sound good? We have to add another sort of physics factor in order to do left-right motion, and that is drag. So drag isn't really, it's not too complicated. Well, it's more complicated than just straight gravitational acceleration. What drag is it's an acceleration that's exerted against you proportional to how fast you're going, right? So just before we break, so if you guys during the break, if you want to like noodle around and see if you can get it working. So the idea is when you, as you are holding like the left key or whichever one you want, you apply a uniform acceleration, right? At a certain velocity, the force of acceleration will be perfectly balanced by the force of drag x. So you will maintain constant velocity despite the fact that you are, like, in theory, still accelerating. That's how left-right motion works on a character like, for example, Sonic the Hedgehog. A little bit like on the old Mario engines, I don't think they went to, like, this far with it on, like, Super Mario Bros. But this is the type of stuff that you're talking about for, like, probably anything from like mid NES on. This is like the model that's used. Okay, 15-minute break. We shall resume class at 10:32. Very good, thank you very much. Right, so let's talk drag. This class is such a drag. So, when I was saying that our drag term should be proportional to our velocity, that's true. It should be proportional to our velocity, but it should also contain a constant term. You can imagine that if the effect of drag was simply to, for example, divide your velocity in two every frame, you would decelerate, but then your character would continue to sort of slowly creep forward, right? So what you want is some constant term plus some a value multiplied by the velocity. So, in order to get there, we have to start working with, basically we have to flesh out the x velocity and acceleration, similarly to here. Player dot x velocity, set that initially equal to 0. Player dot, player dot x acceleration we'll give that a 0 as well. So we want the x acceleration to be non-zero so long as the key is, like the left or the right keys are being held, right? So we're going back down to our keyboard event listener. Else if event.key, are you folks arrow keys people or are you WAS people? WAS people? Okay, alright.
Arrow.
Alright, all in favor of arrow keys? All in favor of WAS? Alright, WAS has it.
I haven't even played RPG. Might go to this.
So, player dot x acceleration is equal to, let's say that we've got a player speed, let player speed equal 0.5 maybe, we'll see. In theory, we should actually bundle that together with the player object, shouldn't we? Jump power 4. It's fine. It's fine. We'll just do it. Worry about refactoring it later. By the way, when you go through all of your code and change something, That's called refactoring. That's the term for it. Out of here. Player dot x acceleration equals negative player speed. There we go. And if this is the wrong way around, we'll just reverse it. So this will give us a player that hopefully accelerates when we hit D, A, D, 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 D. Well, I forgot something. I'm not updating my x coordinate physics. Whack whack. There we go. Now let's try it. D. Nice. Well, we do have motion. And here's a cool little thing. If we make a pit for him, right? Oh, he skipped right over it. Let's make it closer. Oh, okay, wow. Oh yeah, because we're not interrupting, we'll figure that out. Let's just, you did notice that he took a dive off the cliff. Alright, okay, cool, it's cool. It's all good. We're making progress. We do want to put the bit in where he stops accelerating if we release the key. So, this is now just player control. Document dot add event listener. Key up. Hope that exists. So you can actually play with the left and right here as well, but it's not stopping when I'm stopping. Oop, I didn't mean to close that. Whoops. All right, there we go. What was key up? On key up. Well, this is just key down, and that works, but on key up, we'll try. Nope. You're gonna make me look it up, aren't you?
It is key up.
It is key up. we go. There we go. So that's actually better, because that was, if you'll notice, it stopped accelerating. Right? I can kind of get it to move with constant velocity. Now, the thing that should take care of this from here is our drag term. So, going back to our player physics simulation, basically, okay. Can anybody tell me is Newton's first law? Newton's first law of motion? It's the second law, I think. Force is equal to mass times acceleration. Right? So, like, I've been referring to this as drag force, which is true, right? I've been referring to, like, our negative y acceleration as the force of gravity, right? But, like, you may notice I'm not using the term force, I'm using the term acceleration. Basically, if you assume everything has a mass of 1 kilogram, then you can work purely, like, acceleration is the same thing as force. So, that's the approximation we're making here. If you wanted to do a more in-depth physics simulation, you would give objects mass, and you would not apply acceleration to them directly. You would apply force to them. It would take into account the mass, but we don't have to do that. Maybe you guys do when you guys do your assignments. I don't know. If you want to, beef up the physics system. If you want to take this and run with it. Oh, I should probably, like, lay down the rules for that. So, if all you do is take an in-class example and, like, change the color and hand it in, don't expect a good grade. I know the in-class examples that I have given to you. I know what's on my YouTube channel as well. If I see, like, a barely modified version of what we've done in class, I won't be impressed. And in this case, not being impressed means not getting a good grade. So if you want to if you want to use this as a basis, I'm happy for you to do so. That's kind of the reason I'm doing it in class. But you need to put some work into making it something else. Right? I think that's fair. Right? Either, like, you take this and you extend it in any of a number of different ways, or maybe you, like, rip it back a little bit and build it up from a previous point. I said at one point that, the block level, like the level array, that element, you can do a lot of stuff with that has nothing to do with Antcraft. Like, you can build a Tetris engine out of that if you want to, right? Yeah, so, like, take this and go somewhere with it. Don't just, like, be content to sit here and turn in basically the same thing that we did in class. That won't be a path to a good grade. Okay? Does that make sense? Is that fair? I think that's fair. So, drag. This class is becoming such a drag. So, we kind of want to calculate it actually before we apply the acceleration to the velocity. So let's calculate. Let's first just calculate drag. Let x drag equal. I said we needed some constant term, and then some constant multiplied by the velocity. So our current y acceleration is 0.3. This gives us kind of an idea of where we might put these values. Say 0.5, no, 0.05, pardon me, plus 0.1 times math.abs layer dot x velocity. Does anybody know what math.abs do?
Like, remove minus?
Yes, that's precisely the operation. It's not like, math.abs, no. It's absolute value. It's a much nerdier thing. So, yes. So that gives us the drag. The drag is always in opposition to the direction of acceleration. Always. So, basically, if player dot x acceleration is greater than 0, then subtract drag. Otherwise, add drag. Right? Another thing is that the drag may never exceed the acceleration. Makes sense, right? You can't have something being slowed down by friction so much that it starts traveling in the opposite direction. Fortunately, that's not the way that physics works, right? So, if x drag is greater than player, math.adds player dot x acceleration, then x drag is equal to that value. Make sense? Just caps it at that value. Any questions? I haven't paused for questions much. I've kind of been riffing, So we want to take this. Oh, no, actually, we want to take this one. There we go. Shall we see if it works? So we can actually calculate it, right? The point at which, the velocity at which we no longer have any acceleration, right? Our player's speed is 0.5, right? So 0.5 should be equal to 0.05, 0.05 plus 0.1 v, right? So, algebra! So 0.45 divided by 0.1 is equal to v. V will be equal to 4.5. That is the point at which this, the drag force will be equal to the acceleration force, thus preventing further acceleration. That is effectively our character's top speed. If we want to configure that, all we need to do is play with those constants until we get a value we like. But it's also easy to just kind of run the simulation and see if you like the speed. So, let's try her again. That's our top speed. However, we're still not decelerating. Our top speed is effectively capped, but we are not decelerating. Let me take a look here. Okay, alright. The problem is this guy. This is reading the player's current acceleration, right? So basically this means that if we turn off the player's, if we turn off the acceleration by releasing the key, this value drops to 0, meaning the drag also drops to 0. We want the drag to persist after the player has stopped moving, right? So, let's just substitute that for player speed. There we go. Hopefully, whoop. All right. So, the constant term is doing us dirty now. Maybe we'll just get rid of the constant term since it's causing us problems. There we go. Let's try it now. Rick. I think we need a case for that, actually. I make a little hole for him, he falls in the hole. And then he falls off the edge of the world because we're not doing collision detection in the X direction apparently. So there we go. So let me just explain what I did there. I know I went quiet for a moment. It's actually like, I know this is like not at all like the sort of thing that you would at all care about, but it's actually kind of hard to code and like teach the code at the same time. Sometimes I just need a mental, like, let me focus. So, the problem I was running into is that basically when the player is not accelerating, when you release the key, like this case was still being applied, right? Which means that the drag was being applied. Now, the drag is always opposed to the velocity. We're kind of making a bit of an assumption here that the velocity is in the same direction as the acceleration, which we should probably fix that, but it's good enough for now. If the acceleration is 0, we check to see if velocity is greater than 0. If so, we subtract the force of drag to slow us down. Otherwise, we add the force of drag because we're moving negatively and we want to pull ourselves back to a stopping position. Make sense? So, I think maybe he's just a little too fast. Put another factor on there. There we go. There we go. So the effect of that thing that I said we should probably fix with the if statement is like, I know it's hard for you to see, like catch it, but like when I change direction, he has to come to a stop before he changes direction. Watch this. Change. 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 Right? That's the effect of the code at the present time. I'm not sure that I'm like fussed about fixing that. Maybe I'll leave that as an exercise as a reader. But yeah, so far so good. We honestly don't have that much left to do in terms of mechanics here. Question.
Can we add X collisions?
X collisions is definitely the next thing I was going to do. The other thing I was going to do is filter the block pickup things for there's a bird that wants in. Hello, friend. Sorry, you gotta pay tuition. Birds ain't got money for tuition. But then again, who does? Yeah, X collision for sure, that's next. Filtering for the blocks that are like in a clickable radius around the character for, picking up and placing down, that's another one. But you can see how like with this, right, just sort of as it sits, right? You can kind of make yourself a little platform game, right? Even without X collision, like this is transformable into something approximating Mario, right? As long as you constrain your level design, right? You can't effectively do that yet, right? You can just pass through it, but. Yes.
Yeah, so I have a question. So yeah, at the beginning when you were first asking what type of game you wanted to create, that's kind of like what I pictured, was like a side-scrolling game that was like this, and you kind of just like move something up and down. So if one were wanting to create that, would you recommend making it like shorter so you don't have to create so many blocks? And then do you recommend like some kind of loop where you're like removing the blocks as as they're leaving the screen and then you're adding more?
So, there are a couple of ways that you can do it, right? A way that you can get it to work relatively easily that, you know, it's gonna look a little clunky, but you can get it to work fairly easily, is you simply give yourself a very long matrix of ones and zeros, right? And then in your display script, you have like an offset, right? And like the region of this that I'm displaying is like from there to there. And then, you know, have a the way that these things typically work is like if you have a there's like a trigger line on this side of the screen that moves the offset this way, and a trigger line on this side of the screen that moves the offset that way. So like, you know, it kind of looks bad if like your Mario is like, the camera is always locked dead center on him, right? Like, if I just briefly pull up the YouTube, Super Mario 3, for example.
It kind of is a little bit centered on him, but not really all the time.
Yeah, so you can pretty plainly pick out where that trigger area is though, right? Like his move level forward trigger is about there, right? And if he goes back, I think the other one's like about there. Actually, it's quite close in Mario 3, it's like there. See, you've got that kind of hysteresis zone that like it doesn't move the screen.
Yeah.
Now, like, if one were to compare a game which I had when I was a kid, this one has very bad. This one's very bad in that respect. Like, yeah, I know. Like he's locked to the middle of the screen, but like, if he gets running, like basically as he runs, it sort of moves the camera back, but like you can see how janky that looks, right? It's like when he hits a platform, it pops the camera up, you know? It's very, it's not smooth at all. But he's also like working with a lot more verticality than Mario typically does. Like Mario 3 kind of has 2 levels, and if you jump onto the second level, the whole level shifts up, right? But yeah, this is a good example of a less well-programmed game attempting to do the same thing. Yeah, and you could like most of the time in this game you spend fighting the camera rather than the enemies. And like, yeah, anyway. So it has an effect. Mario good, this bad. If you're gonna imitate anything, imitate Mario. X collision then? Shall we do X collision? Alright. So, let's take a look. Should be a fairly simple operation of just, you know, adding the X components here, right? Our next position prediction is already taking into account X position, right? We're just not arresting X velocity. So let's do that. Boop. There we go. Now let's see if that works. Okay? Hmm. Okay. We have lost the ability to move. This is an interesting bug. So, this one's kind of interesting actually. You may think to yourself, why on earth would we lose the ability to move? Well, let's consider the position that we are currently in. We are on a surface. We are sitting on top of that surface, right? Vertical acceleration is still happening. Every single frame, we are triggering a collision event. It's not really a collision event, like in a game engine it would be a collision event, right? But every frame we've got a collision event, which means every single frame, the thing is attempting to do this and getting popped back up. Its velocity is being arrested every single time, right? I can show you that actually using the console. If we turn my console.log funk, because we hit something, right? Console, you can see we are constantly thunking into the ground, right? So the difference, so if we put the thing that arrests x velocity in the same branch of the if statement as the thing that arrests y velocity, as long as we're in the thunk state, we're not going to be able to move in laterally either. So we need to distinguish between x thunks and y thunks, right? So,
I was gonna say, since the ball is like on the surface, is it if you were supposed to like move it up a bit, would that help?
well, the way that we would pop it up a bit is by just moving the collider up by like half a ball width or something like that. You don't really change the problem, you just move it to a slightly different location, right? You'd still have the problem where you're like constantly trying to accelerate into the ground and the ground has to push you up for you to stand on the ground. That's actually how physics works, right? So yeah, having the ball do that at some offset from the ground doesn't alter the fundamentals of the physics. Now what we need to do is we need to reconsider what we're doing here, right? And we need to basically, what we need to do basically is to project our future position in both the x and the y direction. We need to separate that out. So right now, you know, if we are, say we're traveling through space in this direction, right? And we have a wall here, right? This should not cause full stop. It should cause stop only in the x direction. So what we need to do is we need to test this point here, and we need to test this point here, right? And then do different things based on those. So rather than doing new x and new y at the same time, we take just new y as its own collision check, and just new x as its own collision check, maintaining the old values. Does that make sense? Math? Mathematics? Mathematician? So, this will require a somewhat fundamental refactoring of this block. This block's going to change a lot. Question?
Wouldn't it be a good idea to, like, I'm assuming all that constant dunking
Mm-hmm.
is not, I mean, it's taking resources, or is it not that big of a deal that it's constantly looking for to see if it's dunking?
So if you wanted to make this a bit more efficient, you would build in a kind of a check to see, like, am I moving at all? If I'm not moving, I don't need to check, right? This is the type of optimization that, like, a proper game engine would absolutely be doing, right? For our purposes right here, it's not an issue unless it's affecting runtime, and it's not affecting runtime. As you can see, this thing can handle like 40,000 simultaneous squares on screen at once, so it's, you know, something like that isn't gonna, I appreciate the drive for optimization. In this case, not gonna make much of a difference. So, if you don't use this technique, you should. Take your old code, comment it out, use it to build your new code, right? So let x check, let y check. We shall do x and y checks. Now, we're going to need, so for our x check, we want to check our updated x position, but our old y position. So we'll need to save our old y position. Let previous y position equal player.y position. Just keep it in a variable. Just like that. Ba-boom. Previous y position here, previous x position there. There we go. Right? Now, we do our x check and our y check separately. If x check dot val is equal to 1, console.log x thunk. If, and this isn't an else if either, we want both of these to operate every cycle, regardless as to whether the other one did. Y check dot val is equal to 1 console.log y thunk. There we go. So here, you remember how I said we could, we had basically infinite wall jumps previously? We can now make that a deliberate choice. Suspended false, certainly we want to apply that to y. If we apply it to x as well, that gives us wall jumps.
What does it do? Suspended. What is suspended?
So the suspended, this tells us whether we're currently in the air. It's set by the jump action. So part of jump, the jump routine is suspended equals true. When we hit something, suspended equals false, and we're not allowed any more jumping unless suspended is false. So that prevents, like when we introduced the jump mechanic, immediately we had like infinite double jumps, right? So that means we can only jump once we've hit something. But it also, interestingly, it also means that, and there are some video games that actually do this. If you like walk off a cliff, you get one jump before you, you know, that's okay. That's fine. The trick with a project like this is like, don't get too bogged down in those types of physics-related details, right? You can spend a very, very long time trying to get the physics perfect when good enough would be good enough, right? In fact, it's actually kind of a fun mechanic that if you walk off a cliff, you can jump back on, you know? Is it a bug or is it a feature? There you go. So, if we hit something in the x direction, we should arrest x velocity. If we hit something in the y direction, we should arrest y velocity and reset our ability to jump. Y thunk, and now you can see we have x movability back. If I make myself a little wall, here, jump. There you go. And you can see that bug that you have to come to a stop before changing direction is becoming increasingly annoying as I play with this. So like that just went up a couple of notches on my priority of things to fix. Because yeah. But so do you guys want to see what the difference is if we just put that one line in to put the double jumping in? It's easy enough to play with it, right? It's kind of fun to play with a physics engine, All we have to do is take this line of code, put her there. I think we've made our point with these console statements. There we go.
So if we actually also fix the circle, I feel like it's messing off so bad. Half the circle is in the ground.
It's harder than you think. Basically, I have to go from, in order to do that properly, I have to go from considering my player object being a point to considering it being an area, and like that complicates the math more than you think it would. Although if you keep it as a circle, it's not too bad, but so hop, whoa, hop, 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 whoa. Well, we found a bug. Here, let's see if we can isolate that bug. Does that happen every time we jump into a ceiling? No. So I think what happened there was I managed to actually get the player to be inside of a block, right? The way that our physics engine is currently designed, if you are currently inside of a block, in order to move to the next, in order to get out of the block, you require a one-frame acceleration strong enough to put your next position outside the block, which isn't really possible from a resting position. So you get stuck inside of blocks if you can manage to get inside of one. This is probably, it's probably suboptimal. However, again, this is another one of these things that's in the categories of weird edge cases you can spend a lot of time trying to fix in a physics engine. Good enough is good enough, especially considering the scope of the project for assignment 4. That bird is still trying to get in. Man. You know what I'm saying? And you know who else gets stuck in walls and levels sometimes?
Bird.
well, birds, but also our good friend Sonic the Hedgehog. In like the original Sonic engines, you could, if you were going fast enough, you could get yourself stuck in a wall, and then like the only thing that happens is your level timeout runs out, and then you die and you get to start again. And that was a thing that used to happen with the old Sonic games. Occasionally, there were some tricky spots and levels you had to be careful of. So, does that make sense? Any questions?
Can you show your code? I'm missing my X and my function code.
Sure thing. You're talking about the updated collision code, right?
Yeah, I think so.
All right. So, any other questions? So the last thing that we needed, the last thing that we'd like to do is we would like to check, we'd like to constrain the block removal and placement mechanic so that you have to be like, it has to be a block close to the ant in order to be able to interact with it, right? This is, of course, an attempt to, make it a bit more Minecrafty, right? Minecraft has the same thing. You must be within a certain radius of the player in order to have the block interactable, right? So, what we then require is a function which will give us whether a particular x and y world coordinate falls inside of that radius, right? So, it's kind of similar to world space to block, but it doesn't actually, this part doesn't really require the level, right? We just want like a Boolean out of this, right? Function is click interactable, I guess. Really clunky name, that's okay. Taking an x and a y. So now we need to do a little bit of geometry. So let's say we have a circle. Cx, cy. And let's say we have a point, xy. Maybe inside, maybe outside. How do we tell if a particular coordinate is inside of a circle or not? Right?
The distance between the center and the point, if less than the ratio, is like.
Yes. So basically, you calculate the distance between the 2 points. If that distance is less than your radius, it's inside the circle. If it's greater than the radius, it's outside the circle. And that's all you really need. So, here's the question. I seem to recall asking this question recently. How do you calculate the distance between 2 points?
A2 plus a to the power of 2 plus b to the power of 2 equal c to the power of 2, and then you do like c equal
It's like
square
only
root
theory.
8.
Yeah, the Pythagorean theory, yep.
Okay.
So this distance d is equal to the square root of, in this case, x minus cx squared plus y minus cy squared. Right? Because you want the delta between the two, right? So, good. Very good. Let's calculate the distance. Let d equal math dot squirt. Don't ask me why they abbreviate square root that way, but that's how they do it. Oh man, does JavaScript have the? How do you do X? Can you do it without math.pow?
I think it's star.
I know that's Python.
Did you do the
It is. Yes. Okay. It follows. Okay. I can never remember that. Sometimes it's like the caret, you know.
Yeah.
Sometimes it's 2 asterisks. Sometimes you can only use math.pow. Yeah. So x minus player dot x position plus y minus player dot y position. There you go. Return d is less than or equal to what? We need to know the radius, right? So the radius, that's like, you know, something about the game. So we should put it like with player interactability radius is like in the same category of things as like player running speed, right? So let interactable radius, extremely clunky. I don't know, 20 pixels, 30 pixels, 25, split the difference. 25 pixels, interactable radius. Where was I? Where even was I? There we go. Return d is less than or equal to interactable radius. Baboom.
that word? That's it?
Yeah. Collision between things and circles is easy to calculate. Collision between things and boxes is a bit more math, or a bit more like if statements, anyways. Let's see. So, what have I not done? I wrote the function, but did I use it?
No.
No, gets me every time. So, on all of these, if is interactable x, y. There we go. Doesn't work, except around our player. Oh, hey, I forgot. Oh, guess what? I just figured out what our in-game solution to that bug where you get stuck in a block is. You just get it, you just mine it. Boom, you're free. There you go. We have the problems and we have the tools to fix them. So there you go. And that kind of, you know, that makes it much more of a game, you know? I'm out of blocks. So one thing that I would add to this is like an indicator telling you how many blocks you have in inventory, right? You know, that seems like that would be useful information to know how many you have, right? But yeah.
Let's say you're too far up in the air, you won't be able to collect any blocks then. If you're, like, let's say you're building something and you're far up in the air, you have to come all the way back down to pick up more blocks.
Yes. Yeah, exactly. So, like, you know, although you can, you know, with only 2, you know, you just have to be a little, it's a little, it's not really made for, if you want, like, more precise control, I would recommend slowing down the character, right? At the moment, he's going a bit fast to be able to, like, you know, reposition your position on a single square, right? So, like, right? But, oh, and there's that fall off a cliff, you still gotta jump thing. But yeah. But there you go. Any questions? Anything anybody wants to see if I can throw into this thing in the remaining, yeah?
I think a simple thing to do would be like a hold shift to move slower type thing.
Yep. Yeah. You want to do that? Yeah. Okay. We could do that. We could like tweak. We could continue tweaking the physics. The other thing that we could do, which I thought, you know, that was an idea, is like maybe modify the like level drawing routine and maybe make it a little prettier. So what do you want? You want pretty or physics? Everybody for pretty? Everybody for physics? Okay, I think we might have time to do both. So let's start with prettying things up a little. So the idea with this game is that you're an ant building an anthill, right? So it might be nice to have the top layer here be grass, right? All we would have to do is to turn this top layer green, right? If like, how many people are like deeply and intimately familiar with Minecraft in this room? Yeah. So how do grass blocks work in Minecraft then? Yes. So if you have one one grass block, the grass will spread to adjacent dirt blocks. Right now we don't have in the level the distinction between grass and dirt blocks. That could be somewhere you go with this. We have everything we need to do that. But it's actually like, it would be fairly simple to do something like, you know, if we have our pane, if we have our level, pick a Y level, and in that region, if a dirt block has nothing above it, it is grass and gets green instead of brown. Make sense? Shall we do that? So let's go to our draw level. We're going to make this a bit more complicated. If condition, else brown. So pick a Y level. I think that we're currently doing like 20 is they start init level. Let's see here. It's 10 actually. So let's pick like 12. 12. Yeah, let's do 12. If y is greater than or less than or equal to 12, green. Oh, no, that's the outline. We can say green here and maybe light green. See if that works. Oh, why is not fine? Really? Oh, it would be J, wouldn't it? So, there we go. Right? It's not super duper, complicated, but it has a nice effect. It makes it look a little nicer, right? We could even do this. If so, else. Or else if else. Good grief. You could even turn this into a switch case if you wanted to. Is sky blue a color? Sky blue seems like it would be a color. And then, there we go. Only issue now is that everything has been drawn over top of our player, right? So,
What happens if you change the HTML color instead and get the box?
well, see, the reason that this is happening, right, is because I have my SVG, and like the first element in there is the circle, which is the player. All of the rest of these rectangles are being put after the player circle, which means they're being drawn over top of him. So, I kind of want to like take him and put him to the end of the list. Like it'll draw him on top of the grass and the ground, but layering is now the issue that we're facing. But let me just show you another effect that this has. I think I have it here. Basically, after that set point, right, the background is now black to look a bit more like tunnel, right? So let's see if we can fix that. console.log canvas.children 0. Circle player, good, alright. Circle player, yes, good, good. Basically, we want to take him and like, just put him to the end of the list, right? So, it's a swap operation, just a simple swap operation. Have you guys done swap operations? Okay, mini lesson. If x is 5 and y is 10, how do I get x to have 10 and y to have 5? I cannot simply say x is equal to y and y is equal to x. This does not work.
They have to have another variable and put the like one of them
Yes.
in that, and then
You require a temporary variable, right? Because in this step, we overwrite x with the value of y. Then when we go to write x back into y, it's already the thing that it was before. So that's why the swap, you need a third place to keep the data. So we might say let temp equal canvas.children 0, canvas.children at canvas.children.length -1 is equal to no, sorry, that's the thing I'm assigning. There we go. Then this thing will be equal to the value of the temporary thing. Let's see if it works! Swapping it to the end of the array. Oh, unexpected end of input. Ah! There. Circle is still at the top, right? I wonder if SVG objects have like some kind of layering attribute.
Like that
Can you-
index me?
You have to change it. Hmm. I mean, another thing we could do is just draw the player circle as part of this routine. So, yeah, I know, class is almost done. I think I can get this working. Play that. Radius was like 25, or what was it? Was like 10? Yeah, okay. Good. player dot x position, player dot y position. There we go. Red. There we go. Yeah. We'll need to delete the player object when we do this though. There's also like the small matter of assigning it to player dot dot, which is being used to update it. Player dot dot is equal to this thing that we just made. There we go. All right. Document dot query selector circle dot remove. Let's see if you work. You scallywag. Hey, there you go. I think that probably is too much radius. We got errors. Unexpected attribute length. What? Okay. Bugs. 161. Undefined. Is circle actually what it's called? That's a good question. Well, it is, because there it is, right? It is drawing on top now. I hate ending class on a bug.
How about remove the oval? How about remove this?
Probably no. Like, if that was the problem, we wouldn't see that, right? I think our radius is maybe a little too large. See, it kind of pops over there. I broke something. Something in player has been broken. Probably something about player, like, update. Sorry? No, that's a local variable inside here, so that actually doesn't matter. As long as it's consistent here, it's good. What is dot anyway? It's this reference which is breaking. Maybe if I do something like now. Anyway, I'm out of time, unfortunately. But if you fix that reference here, the idea that I was having was like maybe give it the ID like it had before, use the line that fetches it by ID, and assign that to dot like we were doing before, since that seemed to work. That probably will fix the problems. I don't like having to regenerate the player like every time the level changes, but at least it's not every frame. Any questions? Not bad for 2 classes, eh? All right, thank you very much, everyone. Thank you for your time and attention. I'll see you next week. Have a good weekend. Question?
Before you log, I see your collision stuff.
Will you fix it?
I'm going to be posting the code.
Oh,
Will you be fixing it and posting it?
No.
Oh.
Fixing it is an exercise for the reader.
Alright.
Come on, it's only only one little bug.
Right.
We just watch it, but it's probably.
So it has to be.
Every single time the plane goes right, it makes new spires and then the circle.
That's because he.
It locks you to the rhythm. In this case, like to do the physics simulation, we need kind of need to be able to move
Behind the sky.
in a sub-block way for this game.
Moving the sky.
So, yeah. But no, that's, like, that is good. We could definitely do like, basically what I have to do, what I would have had to do to like get only the top to be grass is to detect non-collision above, in which case something like that would be what you would do.
I don't need to do something like this to get unstuck.
Yeah. Yeah, exactly. Very quickly, now that this is done, next week I'm going to be talking about the next topic, which is Ajax.
Well, I don't know, I'm people go to school. Free. Yeah. Looking cold.